Good morning. Welcome back. We're doing Chapter 10, Section 4. Chapter 10, Section 4, which is Inscribed Angles. Inscribed Angles. If you need a refresher on 10-3, remember that was the stuff that we had not done before spring break, go back to the video and see if you can catch up. We'll start this video with a couple of problems from 10-3, just sort of looking at them. So we have a circle with a radius r is 35. The radius, so P to R is 35. L to M is 80. LM, this line right here, is 45. And LM and NO match. So find the measure of N to O. Since we know these lines match, we know that those arcs match as well. So that means this should be 80 as well. Radius of circle R is 35. This is the exact same thing. Find N to Q. Well, because we have this making a perfect right angle, we know this is cutting it straight in half. So our total is 80. Our half is 40. Find N to O. N to O matches L to M, another 45. So hopefully this made sense, and you can go back, look at these, try these on your own, go on Schoology and grab these. 10-4, inscribed angles and arcs. So we have the inscribed angle theorem. If an angle is inscribed in a circle, that means it's just inside totally, where it's got inside here. Then the measure of the angle equals 1/2 the measure of its intercepted arc. So what it's saying is, let's go to this. I have a circle right here with an angle here to here, let's say. Whatever this is, let's say that this is 32 degrees. If that is 32 degrees, what that means is this is going to be 64 degrees. Now, before we did something like this where this number and our angle match. If you remember, we did this with something like this. We had something like a point in the middle that we would connect here, and we said if this is x, this is x degrees as well. But now we're changing it where we're not going from the middle anymore. We're going from almost a pair of chords to the outside. And it's going to be twice as big as the angle. Sort of like the further you pull back, the more it expands. So the reason this is x and this is x is because it's in the middle. But if I started pulling this back, this angle would get smaller and smaller, and this would stay the same. So this would end up being, it would be half x over here, and this is x still. I know that doesn't make total sense right now, but I think it will be a little better once we start doing some problems. So let's do one. There's your theorem and your proof to sort of show how you get there. So we have something like this. This is a circle with a lot of information given. We have z up here. We have w over here, x, and then y. So we have pieces all around this circle. And it's not exactly this, but it's pretty close to this. We're given that this is 86 degrees and that this is 52 degrees, and we're looking for this angle right here. So we have this in front of us. Kind of no way to put all of it in one picture, but that's okay. We have this circle. We have two different inscribed angles. We kind of have this one right here, and then this one right here. And all this that we're talking about is saying that if we have an inscribed angles from like one side and it's shooting out like this, I imagine like a spotlight, then we can figure out what this is. This, for example, would be 52 times 2, which would be 104 degrees. We can work backwards. So we have 86 up here, and we want to know this. Well, this will just be 86 cut in half, which is 43 degrees. So we can know that this relationship always works out no matter what inscribed angle we're talking about, where if we have the angle, we can double it to get to here, or if we have the arc, we can halve it and get to the angle. So we have measure of x is 1/2 this, 1/2 of this goes right in there, so 43, just like we talked about. Find xy, we did that just a second ago. We took 52 and doubled it to get to 104. We can try this on your own. I would encourage you to pause the video, give it a try right here. Shouldn't be too difficult. You can probably do it in your head, and once you get good at it, I wouldn't encourage you to do that, but you can. To find C, that's this angle right here. That's this inscribed angle. I'm looking at this arc, 94. Since I'm going down into the funnel, I want to cut it in half. I don't want to double it. D is doubling our answer. We don't want to do that. We want to cut the arc in half, 47. Similarly, B to C, since we're going bigger, it's like a crescendo if you're a music person. We're going from 48 to the arc. That's double 48. That'd be 96. Hopefully that makes sense. These are inscribed angles. Theorem 2 is kind of building on that. If two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. What does that mean? So let's draw a little circle. And then we'll do a bunch of inscribed angles in it. All right. So we'll put one here, and we'll call that A and B. So if we look at this, all this is saying is I have these 2 points, A and B, and I'm going to do 3 different inscribed angles coming from here. We'll call that D. We'll try another one. How about from here to here? Call that C. And then finally, let's do a blue. That looks pretty blue. How about a brighter blue? From here to here. And we'll call that E. And what we're saying is, so our spotlights keep shining on A and B, if you can see it, kind of shooting from E to those 2 points. And then similarly with the other ones, we're going from here to there. We're going from C to A and B, from D to A and B. And all we're saying is that every time this is true, that means all 3 of these angles match. They're the same amount. So this is congruent to this, is congruent to this. And that should make sense because we know that whatever this is, let's call this 2x, that this has to be x, and this is also x, and this is also x. It doesn't matter where our point is on here. What matters are that A and B are where they are. This distance matters the most. Not as much where this sits. We could have it be in the red location, the purple, the blue. We could even have it like over here, but it'll always be the same amount. That's what this theorem is telling us. In this case, A and D are ends of the little spotlight, if you will. So we have something like this. We have finding the measure of R is 12x minus 13. We have S to be 9x plus 2. This one's a little tougher to see where the spotlight is and where it's pointing at. So let's try to dissect that together. We have a line cutting it right in half, something over here. And then this goes here to here, and this goes here to here. Okay. So we know this is 12x minus 13, and this is 9x plus 2. So to find this, we have to think about, well, what are the spotlights pointing at? And hopefully you can kind of see them in, let me zoom in. So this is our problem. If you're trying to find where they're coming from, we're going to use these endpoints. These endpoints are like our guides. So hopefully you see this is one because we're given this. And then this is one. So that means our spotlights, I just keep using that word because that's what I keep thinking about, are from here to here and from here to here. There's one, and the other one is going to the same location. It's going from here to there and from here to there. So this one is this blue one. Hopefully you can see that. And this other one is, we'll use a red. So we know that they're going to the same locations. They're pointing at the same thing. They're pointing at these 2 points. They're just originating in different places. So that way I know 9x plus 2 and 12x plus 13 are equivalent. 9x plus 2 equals 12x minus 13. And then we just have a simple algebraic equation to solve now. Minus 9x, I have 2 is 3x minus 13. I'll add the 13, I'll add the 13. 15 equals 3x. So x should equal 5. We don't want that as our answer. We're actually looking for r. So we're going to throw 5 back in here. We actually could throw 5 in either of them because they're equivalent. If we put 5 in, we should see 5 times 12 is 60 minus 13, 47. Once again, we looked for these angles and they're pointing at the same thing. They're pointing at the arc TQ. If you can't see it, I encourage you to draw it out yourself. Maybe just draw this arc, this angle, and then this angle to sort of see what's going on. Find measure of angle I. So I and J are both pointing at H to G. Bum, 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 bum. And so you see it, set them equal to each other, find X, plug it back in. Another theorem, we're adding a lot of theorems today, but hopefully you can see they're all kind of connecting together. An inscribed angle of a triangle intercepts the diameter if and only if the angle is a right angle. So what that lets us know is that if we have an inscribed angle that cuts through the triangle in the diameter, that means it is a right triangle. That means it is a right triangle. So we have something like this. If I have a point here that goes here and here and here, that's letting me know this is a right triangle. Hopefully you can, I don't know if you can see that. There's your right angle. Because the part that goes through the diameter is always going to be your hypotenuse because it's the longest possible place you have in a circle. So since we know this, we can solve these things as we would any sort of right triangle problem. So we're back to doing those again. We have this, we have A over here, B over here, and this is cutting through the middle. This is over here, and then this is here. So we have a right angle. It's not labeled here, but we should know that we do x plus 4, 8x minus 4. So with this problem, we have these things. What we're trying to find is measure of angle B. So So we want to find this angle. We need to do a little bit of work beforehand. We want to find that angle. I encourage you to pause the video, try it on your own, see if you can find X right now, but we'll do it together. So pause the video if you need to, and then come back in when you're ready. The way we're going to do this is find what X is equal to. Well, how do we know what X is equal to? I know this is a right triangle, so I know this is 90 degrees, and I know these two add up to 90 as well. Because I have my whole triangle, they're going to add up to 180. I've already used my 90 in the corner, and then plus X plus 4 plus 8X minus 4. So this gets me to 180. 90 plus 9X. And then those 4s are going to cancel out. They're just going to go away. I'm going to take away 90 over here, take away 90. And I get 90 equals 9X. So X is going to be 10. If I want to find what this is, 8 times 10 minus 4, that's 80 minus 4, which is 76 degrees. So once again, we had a circle with an inscribed triangle. We have a triangle going through it, but the important thing was that this triangle was going through the middle. Because it's going through the middle, that let me know it is a right triangle. If it wasn't going through the middle, it just existed somewhere else, that we couldn't do this problem exactly like this. But since we know it's through the middle, I knew this opposite angle was going to be 90 degrees. From there, I knew these two angles had to add up to 180, so I solved it for X. Let's make sure we got that right. We go through here. Exactly what we did. Perfect. So we plug 10 in and we get 76. Once again, because we were going through the middle, we could go across and mark this as a right angle. Give this one a try. I'll do this one as well in a second, but pause the video, come back to it when you are done, and it's sort of, and you can check or follow along with me. So we need a circle. Please be drawing these in your notes. That's the best way to learn it. I want you to have all of the pieces that it takes to solve this at your disposal. All right, not perfect, but it'll do us in a pinch. 8x plus 4. Once again, because I'm going through the middle, I know I can go across the circle right here and mark this as a right angle. I have a right triangle. It's kind of wonky. You can see in mine, but yours is probably perfect. Because I know that, I know all of these add up to 180. I've already spent 90, so 2x and 6 and 8x and 4 have to get me to 90. Once again, I've already spent that 90, so I subtracted it. I'm left with just this. That is 10x plus 10. So I move the 10, move the 10. 10x is 80, divided by 10, divided by 10. X is 8. In the problem, we want to find angle D, which is this one. They're not the same. They could be sometimes, but in this case, they are not. Trying to figure out when they will be a good little problem for honors. How would you know when they're always the same? So we're trying to find this. We have X now. 16. It's 2 times 8 plus 6 plus 6. 22 degrees. If we really wanted to check our work, we could plug in here and we would hopefully get the complement of 22, which would be 68. So 22 degrees, is that an option? Yes, that looks like option C. Does that work for us? Perfect. 22. All right, and now even another theorem. We're trying to put in all these theorems, and hopefully you see what these theorems are saying is if we have a shape inscribed in a circle, all touching the edges, that means we know things about it that aren't marked. We're not saying that there's things we have to find. It's saying there's secret patterns that we're trying to use. So if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. And its opposite angles are supplementary. We have a circle, and it has any sort of quadrilateral. So on your own, take your circle, draw any 4 points you would like. They can be weird, they can be wonky, they can be anything you can imagine. It does not have to be a square, a rectangle. It can be any sort of four-sided shape. And I'll put a little place in the middle. What this is saying, so let's go to the zoom in. We have this circle and we have this shape. No matter what four-sided shape you draw in it, once again, I encourage you to, on your paper, draw a circle and draw 4 points and connect those points. They can be as close to as possible, they can be as far away from as possible. But what this is saying is opposite angles are supplementary. Remember, supplementary, add to 180, and opposite angles. So that means this and this equal 180 degrees. We know for a fact that all 4 of these have to add up to 360. And so no matter which ones you draw, this is going to be our 3 and this will be our 4, that these make 180 as well. So any quadrilateral you can draw in a circle will have this pattern. It's an interesting thing to think about. Why does this always happen? That is beyond the scope of what we can do online. But I hope you'll try this out and try to find a quadrilateral without 180 degrees. But this lets us know that there's always patterns. There's patterns in every circle we're going to draw. There's something you can sort of figure out just by looking at it. So knowing this, we can solve all sorts of problems. We have an insignia is an emblem that signifies a rank, achievement, or membership, and so on. The insignia shown below is a quadrilateral inscribed in a circle. Find S and T. S and T. I would copy this in your notes so you have this, and we can put one here. We can, I think kind of here, here. It looks like here. Okay. We have a box over here. We have 14x here and 8x plus 4. What we're looking for are 2 things. We're looking for S and T. Actually, let's just find them all. Let's just find V, U as well. All right, so here we are. This one's easy. We're given what this is. This is 90 degrees. That is 1/4 of our problem done. We want to find all these angles. This one's 90 degrees. It's a little box. What we just talked about lets us know that since we're inscribed in a circle, its pair on the other side matches to make it 180. It's like Jerry Maguire when he says, "You complete me." So we have 90 to something. That's 180 minus 90. Hey, turned out to be 90 as well. So it's not always the same number. Don't hear me when I say that. It's not always the same number. But what it is it makes 180. So for the next two, 8x plus 4 and 14x. 8x plus 4 and 14x. 8x plus 4 plus 14x get me to 180. Opposite pairs equal 180. So I can add these together. 8 and 14 is 22x. plus 4 is 180 minus 4 minus 4. So 22x equals 176. Does that work out? I don't know off the top of my head. Luckily, we have our calculator. 176 divided by 22. Perfect. It is a nice round number 8. So if x is 8, I just come over here. I can type 14 times 8 to get 112 degrees. And then for the last part, 8 times 8 is 64. That'd be 68. Also known as the supplement to 112. These two will add up to 180. Quick way to check all my work, I can add all these up, and I should get to 360. Once again, opposite sides add up to 180. We had a pair this time that were the same, that were both 90, but these were not the same, but they did add up to 180. Remember, any inscribed four-sided shape you could make. You could see this shape and this shape are very different. But these, it still holds true to the property. So we know circles are 360. We know four-sided shapes are also 360. This one guarantees that opposite sides will match in that way. There's all the work. That got to 68. That is for T, the corner. We have a similar one. I encourage you to stop the video, try this one on your own, copy it down, see if you can do it. These are the best practice you can get when you're going through these notes, where you can stop the video and have a chance to solve it yourself. So do that right now. Maybe even find L as well. All right, and if you got that, your answer should be 48. If N is 48, we know L is the complement or the supplement, so it would be 132, I believe. All right, that is inscribed angles. Not the easiest lesson, but I hope you go back if something wasn't clear or reach out. I will be there to answer any questions you may need. Until next time, good luck, and I will see you soon.